Hi guys, good afternoon. So today we'll start with the SNMP, Syslog and AAA. Okay. If we talk about SNMP and Syslog, both are monitoring tools. Okay. Syslog is all about log messages. See, whenever we are using a router, we go and give shutdown command, no shutdown command. So we get a log message, right? That the interface went down, interface went up. We configured BPD filter there, we got the log message. So Syslog is a way to centralize all the logs. Syslog is a way of centralizing all the logs. You can get the logs in a device itself, but in a network, you can have hundreds of devices. So you can centralize all the logs in a dedicated syslog server. Okay. And SNMP, see, a log message will be generated if something has already happened. You have given the shutdown command, then only you will get a log message that interface changed state to down. If you have given no shutdown command, then only you will get the message that interface changed state to up, right? So syslog will give you what? Historical information. Something has already happened, then the log is generated. But SNMP is something that will give you real-time information. SNMP will give you real-time information. That means in the real time, with the help of SNMP, you are able to check what is the CPU usage in the device, what is the RAM usage, okay, what is the bandwidth usage on a specific interface. All these things you are able to check in the real time. Okay. So first of all, let me explain how your SNMP works. So this is the architecture of your SNMP. Okay. In SNMP, you will have two entities. Okay. Major role will be played by the two entities. What are those two entities? One is your SNMP agent and second one is your SNMP manager. Okay. Both are software programs. SNMP agent, this will be installed in all the devices in your network, like routers, switches, firewalls, all those devices. Okay, all the devices that are there in your network and you want to manage, in all the devices, SNMP agent will be present. Okay, and those devices, what you will call them? Because you will manage all those devices using the manager. Okay, now what this SNMP agent program will do, your SNMP agent program, it will monitor the device. What is the CPU uses, RAM uses, whatever the statistics you want to check. So it will be checked by your agent program. And then your agent program will store it in the MIB. Okay. Your agent program, it is going to store it in the MIB everywhere. Each device will have its own MIB. MIB is management information base, where it will store the information, all the stats and statistics. This is clear. Now, we have manager. So manager will be what? Centralized. This will be centralized. That means you will install the manager in one PC. Consider it as admin PC. Okay. So you will install the manager program in one PC, and then this manager, we can use this manager software to manage all these SNMP devices. Now, let's say, for example, from this PC, I want to check what is the CPU usage on this device. So what I'll do, I'll send a message from here. Okay. Your manager will send a message to this guy. Okay. And that message, you will call it as a SNMP get request. This one you will call it as a SNMP get request. And then whatever you will be asking, let's say you are asking about CPU uses. So that relevant information, your agent program is going to send back to your manager. Okay, your agent program will send the information back to manager. And for that reason, it will use the message SNMP get response. This is clear. Manager will ask about information, get request. Agent will send the information, get response. Okay. Now, with the help of manager, in this particular device, we can configure threshold limits. Okay, we cannot just monitor, we can manage the device. We can do some configuration. Okay, So I can configure that, okay, if the CPU usage goes greater than 50% or 40% or 20%, whatever I'll set, then alert should be generated. Then alert should be generated. So what will happen, let's say on any system, take example of this system. This particular threshold limit has been reached. So what this device will do, this device is going to push a message. This time manager is not asking about the information. Your agent is itself sending the information about any sort of special event happening in the device. Okay. You can consider, the violation of port security can be considered, or in a router ACL violation can be considered. Okay. So you can consider different scenarios, any sort of special event. CPU uses are high, RAM uses are high, bandwidth uses are high. Okay, any sort of special event is there. The agent will push the information to the manager. And for that reason, it will be using a message which will be known as SNMP trap message. This is clear. Now, let's say your manager is asking about any sort of information. Talk about CPU uses only. So how your agent will come to know that what the manager is asking, right? There has to be something to identify the specific entity that the manager is asking. So to identify that, they will be using something called as OID, which is stands for Object Identifier. Simple Network Management Protocol. Okay. So your OID is what? Object Identifier. This is used to identify like what entity your manager is asking. Okay. And this object identifier is just a number separated with a dot, like 1 dot, 3 dot, 5 dot, 7 dot, 2 dot, 4 dot, 6 dot, 8 dot. Any random series will be there. Okay. And it will be like this, a large number separated with the dots. Okay. Now, SNMP works on two port numbers, port number 161 and 162, as well as it uses UDP. That means protocol number for SNMP will be 70. Okay. Now, for the SNMP get request and response, the port number that will be used is 161. And for SNMP trap messages, port number 162 will be used. This is clear. This is your how your SNMP is going to function. Your SNMP agent, it is pre-installed in the devices already present. Okay. And manager, we have to install it in the system. This is clear. Okay. Now, this is the practical part, that how it works. Now the same thing will be there in the theory. So now let's go to the theory also. So what is SNMP? Simple Network Management Protocol. This is the full form. Is an internet standard protocol used for monitoring and managing your network devices which are connected over IP. So SNMP will collect data from different network devices like your routers, your switches, printers, firewalls, CCTV cameras. That means anything you have in the network that are SNMP enabled, and it is going to organize them. With a set of operational standards for management, your SNMP aids in network fault detection. So if there is any fault, trap messages will be there, and it will also analyze the network. Thus, SNMP is an integral part of interoperability between both the monitored as well as monitoring system. Both have to function together. Without the agent, manager cannot do anything. Without the manager, agents are not useful. Okay. SNMP will generally use user datagram protocol UDP port number 161 and 162. And for security, your SNMP can use TLS or DTLS security. Okay, these are the protocols that can be used for security. This is clear? Okay. Now, why do you need SNMP monitoring tool? See, with the help of SNMP, we can easily manage and monitor entire network, right? That means if anything wrong is going on in a device, automatically we will get an alert. But if SNMP is not there, then you have to manually go and check individual device. So your network admins, they generally manage the device in a network, allocate and free up the ports and interfaces to ensure continuous uptime and bandwidth hog-free network operations. This is the day-to-day task that you have to take care of your bandwidth. You have to make sure your network is continuously up and running. Okay. And you have to take care of, allocating the ports and free up the ports if something is not in use. Those are the things you have to do. So how you will be able to do it? By closely monitoring all the SNMP devices. So closely monitoring your SNMP devices is a major part of this. SNMP monitoring, it will require the admin to configure the SNMP agent to send the monitoring data to the manager. This is what we have to do. Okay. And with the SNMP, what is the best thing that your SNMP can automatically discover all the devices also. Okay. Since the network management tool will take care of monitoring, admin can just focus on performing the corrective measures. This is clear. That monitoring is being done by this. Admin will get an alert, perform the corrective measures. Then after, your SNMP monitoring tools, why they are necessary? First of all, they can automatically discover, monitor, as well as manage the network devices. They can monitor key performance matrices at the device level, like CPU and RAM uses, at the interface level, like bandwidth uses. With the help of SNMP, you can obtain complete visibility and granularity into the performance of the network device, that how your network device is performing. Okay. Then you can configure threshold limits and generate alerts in case of anomalies. This is why your SNMP is needed. Okay. How your SNMP works? So see how it works. Traffic flows across your network from different sources, right? Multiple different sources will be there. And SNMP is going to communicate with the whole network and the devices in it. And as I mentioned earlier, SNMP is pre-configured, the agent is already pre-installed in the devices. And once the protocol is enabled, the device will store their performance states, where each network server will have multiple MIB files. And the device MIB files, they are required to fetch the monitoring data. And the working of SNMP will revolve around its component, wherein each component contribute to the management of resources. Without anything missing, everything has to be there, everything has to function. Okay. So SNMP works by sending a protocol data unit, which is known as GET request, and the agent will respond to that message using the SNMP GET response. And all of the SNMP communications, they are tracked, and your network monitoring tools, it will use them to fetch the data from SNMP. Clear? The diagram I have already explained. Now let's talk about the components of your SNMP. So same components will be there, your manager, your managed devices, your MIB, your agent, OID. Okay. So first thing is what? Manager. The SNMP manager is the central system used to monitor the SNMP network. Okay. And also the system might be known as NMS, Network Management Station. An SNMP manager is responsible for communicating with the SNMP agent implemented network devices. It will communicate with them. And your manager, it will run on a host on the network, on one system on the network it will run. And then it will automatically discover all your devices and it will start managing them. Okay. The manager will require the agents. Agents have to be there. Then it will require the agents to send the response messages. Agent manager is able to set the variables in the agents, and also it will acknowledge the events. If they are sending a trap message, manager will send an acknowledgement also that I have received your trap message, right? Then we have the managed devices. What are the managed devices? Whatever the devices you have, router, switch, printer, wireless access points, servers, whatever the things you have. Okay. Then what do we have? Agent program. So the managed devices, they are going to have this agent program installed. Okay. So an SNMP agent is a software process that is going to respond to the SNMP queries. Okay. to provide stats and statistics about the network node. So SNMP agent will play the most important role. Why? Because it is responsible for sending the information to the manager. Okay. They are locally located on the device and associated with the SNMP network devices. And from the device, they will collect, store, and transmit the monitoring data. So the data will be transmitted to the designated SNMP manager whenever required. Whenever needed, agent will send the information to the manager. MIB. So MIB is a structure that defines the format of information exchange in a SNMP system. So it will collect all the information. And how they will identify what they are asking? Using the OIDs. OID stands for object identifier, and they are identifier strings of numbers which are separated by dots. This is clear? Okay. Now, Syslog, we already know that it will just generate the log messages. SNMP idea we got. Now we are going to differentiate between the SNMP and Syslog. So your SNMP, what it is going to do, it is going to perform remote monitoring of SNMP allowable devices. We can remotely monitor them. While your syslog is just going to exchange log messages, it's not going to do anything else. Just the log message will be generated. And if you have configured a syslog server, the device will push the logs to the syslog server. We cannot check what is the CPU usage, RAM usage. Those things we cannot check. Okay. SNMP is used to alert on critical actions. So SNMP can generate alerts on critical actions, whether it be your HSRP state change, BPDU guard violation, port security violation, ACL violation, any sort of thing. So SNMP can generate alerts, but your syslog, it will just allow the log messages. That's it. Okay, with the help of syslog, you cannot generate an alert. If you want to generate alerts with the syslog, in that case, you need to deploy SIEM solutions, different thing, completely different thing. Okay. Your SNMP works on the poll and resource mechanism. That means kind of active communication you have with the SNMP. That means I can ask the device about information, and if device feels that, okay, something important is there, device can push the information to me. But your syslog just works on the push mechanism. Generated log, that's it. No active communication. Okay. With SNMP, we can check the information in real time. So it gives us real-time information, while your SNMP will give you historical data. Something already happened, then only. Because with SNMP, I can say that, okay, if the traffic is building up in a device, if the CPU uses are going high, so at 50% itself, it will generate alert for me. So I will know that, okay, this device is going to be, let's say, consuming all the CPU. So I can look for the alternatives and solution. But syslog will just generate a log message if it is already done. Okay. With the help of SNMP, we can perform end device configurations like, threshold limits I can set, I can reboot the system. These kind of configurations I can do. But with syslog, no end device configuration can be done. Your SNMP, it will like the trap messages, they will be shared in the binary format, and SNMP can use DTLS and TLS security. Just we study, but syslog will share everything in the clear text. Okay. SNMP secure uses TLS and DTLS. This is insecure. Okay. Here active communication we have. Here no active communication or passive. It will use UDP port number 161 and 162, and it will use port number 514, TCP and UDP. This is clear. Okay. Now, if you want to see a small practical, I can show you for this. But if you feel it is going like, if you are not understanding, you can already let me know, because it will come in the CCMP again. Okay. I just want to show you how a manager looks like. Okay. Server is down. I won't be able to show. Server is down, not possible. We'll see tomorrow. Right now, I'm not able to connect to the server. So, this. Syslog small practical I can show you. So what I'll do is I'll take a router. Okay. And I'll take a server. Router. This is Syslog server. Subnet mask I'll use default only right now. Gateway not required. Why? Because same network. Configuration terminal. Done. Then after, see, now it will start generating the log message. IP address already configured. You can test the communication. We should have the communication with the syslog server, right? Now here, if you see, if I go here and if I check in the services syslog, so it is already on. And right now you can see there are no log messages. Now I'll go here and I'll say login, host, and server IP address. This is all the configuration you need. Okay. Now I'll say interface gig 0/1. Already shut down script. No shutdown log generated. Shut down. Interface gig 0/2. No shutdown. Shut down. Okay, like few log messages I have generated. You can find all of them here. Okay. So right now here message is not visible, but if you double click here, you will see Z0/2. Change state to up and down. This is about Z0/1. This is how your syslog works. Clear? Now this is, I'm showing you very brief here. Okay, because these things will come again. But this is clear. SNMP, the server is not connecting, otherwise I would show you, but let me give you the name of the manager that you can use. So many softwares are there. One of the software is PRTG Network Monitor. This is a tool that you can use as a SNMP manager. Okay. This is the tool. So they will give you 30 days of free trial and you can just test it in the trial. Then we have three terms to understand about AAA, which is authentication, authorization, and accounting. So authentication means verification of the user. That means you're verifying whether the user is correct or not. How? You give username and password. Like you log into your internet banking. What do? You give your username and password. If username and password is correct, you will get access. Otherwise, you will not get access. So AAA is a standard-based framework that is used to control who is permitted to use the network resources. Okay. So how? Through the authentication. And what they are authorized to do once they have logged in. Now what they are allowed to do. Now what they are allowed to do. So that is what authorization. That means defining policies, restrictions. That is what authorization is. And what is accounting? Capturing all the events. That means keeping a record of all the actions performed by the user. Okay. So what is authentication? The process by which it can be identified that the user who wants to access the network resource is valid or not by asking some credentials like username and password. In the telnet, we have very well configured usernames and passwords, telnet and SSH configuration we have done, right? So the common methods are to put authentication on the console port, auxiliary port, or VTY lines. Clear? As a network admin, you can decide how, like we can control how a user will be authenticated, whether you want to authenticate using username only, sorry, using password only, with username and password, or else if you have AAA, how you want to do it. So we can decide if someone wants to access the network, then how they will be authenticated. But once the user is authenticated, now what the user is allowed to do? Now again, remember the telnet configuration. We created two users, one Cisco and one admin. One user was having privilege level 1, not even able to go to the privilege mode, not even able to check the configuration. How did we put? That user also gave username and password, authenticated, but after that, there was a limited access to the user. That was what? Authorization. So one user was not authorized to check the configuration, another user was having unrestricted access. Okay. So your authorization, it provides you capability to enforce policies on the network resource after the user has gained access to the network resource through authentication. So basically, after the authentication is successful, authorization can be used to determine what resource is the user allowed to access and the operations that can be performed. Kind of defining what the user can do, what the user cannot do. That is what your authorization is. And accounting means what? Logging everything, recording everything. It provides means of monitoring and capturing the events done by the user while accessing the network resource. Okay. So while the user is accessing the resources, what the user is capable of doing, what the user is not capable of doing, everything it will record. Okay. So it even monitors how long the user has access to the network. So what time the user logged in, what time the user logged out, what all the commands user executed, what was the effect of the commands, everything will be recorded. Okay. And the administrator can create an accounting method list to specify what should be accounted for and to whom the accounting record should be sent. That means what should be logged and the logging report to whom it should be sent. Even that we can define. Is that clear? And for this, you will require protocols like Radius, TACAX, and TACAX Plus. These are few protocols that will be used for AAA purpose. Now, again, we don't have configuration here, so I'll not be able to show you here. But again, in your CCNP, you are going to see. Okay. Wherever possible, I'll show you the configuration part also. But right now, this is not possible. Okay. Now, any doubt in this part? No? Then let's start something interesting. IPv6, right? This is where we can do some part of configuration. So one topic of configuration I'll keep today, one topic of configuration I'll keep for tomorrow. Otherwise, tomorrow also complete theory. Okay, because most of the configurational topics we have already done. Now small topics and theoretical topics are remaining. Okay. When we discussed about IPv4, we saw differences between V4 and V6. One of the difference was number of addresses. Okay. One of the difference was about number of addresses. So we know that, okay, in IPv4, 2 per 32 addresses, and in IPv6, 2 per 128. No need to remember the exact number. Okay. Another difference we know is about size, that V4 32-bit, V6 128-bit. This was the difference. Another difference, octet, hexstate. This was the difference, that IPv4 has 4 octets and octets are separated with a dot. And in IPv6, we have 8 hexstates and these hexstates are separated with a column. Then finally, we came to the conversion part, right? Decimal to binary, binary to decimal conversion. Now here we will perform what? Hexadecimal to binary and binary to hexadecimal conversion. Okay. See here, we know that in IPv6, this is what? 1 hexstate. Total 8 hexstates are there. So one hex state, how many bits? Total 128 bits. So 128 divided by 8. 16. 16 bit is the, and you can say group of 16 is what? Hex state. Right? Group of 8 we call octet, group of 16 we call hex state. So this is 16 bits. How many digits are there? How many bits are there? So that means each digit will contain how many bits? 4 bits. This is all you need to remember. Remaining things you already know. What do you know? Let's say I need to convert this hexadecimal value into binary. So I will write it down like this. Right? What is the binary of 2? What is the binary of 2? Only 10 it is, but we have to make it 4 bits. Any value binary, just normal decimal to binary conversion, all you have to take care is it should be 4 bits. This is your hexadecimal to binary. See how easy it is. Next one is what? 0DB8. 0, D, D, and 8. Now 0, 4 times 0. D is what? 13. So 13 means already 4 bits. B is what? 11. That means 8. This is your hexadecimal to binary. If you have been given a binary value, let's say this is number again given, something like this. 1 0 0 0 0 0 0 0 1. Let's say this is binary given. And now you are asked about that convert it into hexadecimal. From binary to decimal, what we did, same scenario. Start from right to left. But before directly converting, what do you have to do? Create a group of 4. This is 4. This is 4. Now this is only 2. Write 2 zeros. This becomes 4. Now what? Same thing. This binary to decimal, 2, 0, 0, 1. This is your binary to hexadecimal. All you have to do is from right to left, create a group of 4. And then normal binary to decimal conversion. That will become your hexadecimal. Is that clear? Okay. So hexadecimal to binary, binary to hexadecimal is clear. Simple thing. Just write down the separate value, convert into 4 bits. And same way, if binary is given, make a group of 4, convert into decimal. This is clear? Okay. Now here, one more thing you have to remember, that in IPv6, we know that total how many bits are there? Same like that in class IPv4, 32, right? So the maximum number of network bits that is possible in IPv4, after slash, what we can say? 32. In IPv6, what we can say? That is the maximum number of network bits. Because see, in an IP address, everything will be either host bit, network bit, or combination of both. IP address is made up of 2 parts, right? Same thing here. Now, whenever you will take an IP address from your service provider, whenever you will take an IP address from a service provider, guys, please wait a moment, I'll be back. So when we are taking the IP address from ISP, okay, so what your ISP will do is your ISP will assign you with /64, sorry, /48. Okay, let's say for example, this is one IP address you can see. So whenever I'll ask my ISP that, okay, I need an IP address, my ISP will give me something like that, okay, you can use a network. Okay, first point is what? ISP will assign /48. Okay, so means what? I'll ask my ISP and my ISP will say me that you can use 2001. 16, 16, 16, 48 bits. Okay, so ISP will tell me that, okay, you can use this network. Now what I need to do, I need to go for the second point, that whenever you assign end hosts are assigned with /64. When you will assign to the end host, your end host will be assigned with /64. Okay, so now let me explain using whiteboard here. First point was ISP will assign /48, and second, your end hosts are assigned with /64. Okay, now see in IPv6 how the subnetting is. I asked my ISP told me that, okay, you can use 2001 colon 0 db8 colon 0010 /48. This is the network you can use. Okay, then what? I have to design my networks. So when I will assign my end host, they will be assigned with, that means how many extra bits I need? Bits. 16 bits I need. That means one more X state I need to know. So what will happen? I will say, I will design my first network for my first department 0010 colon 0000. This is my first department. I can assign with /64, right? Let's say this is my IT department. Now let's talk about the HR department. So what part my ISP has assigned me, I cannot change that part. That is fixed. But what I can change, right? 2001, then 64. Next is what? My sales. What I can do? 0010 0002 /64. Yes, but it will go up till F. So if you see, if I have an IP address, let's say out of this, if I will design my first IP address in my IT department, okay, so it will be what? 2001 0 db8 0010. This is part I cannot change. And again, I added 16 extra bits. So this is also network, because after slash, it is network bits. Now, remaining part is what? Let's say first IP address I will try. So everything 0, 0, 0, 0, 1. Let's say this is my first IP address. So in this IP address, my this part, this is my assigned by ISP. This is what my network part. Okay. Then this is the part. Sorry. The last 64 bits, host part. And in between you have something, right? These 16 bits that we are manipulating for each department. This we call it as a subnet. And this is your subnetting. All you need to change is what? this one. You change this, your subnetting is done. Okay, 0, 1, 2, 3, 4, like that. So how many bits are there? 16 bits are there. So if I am taking one network from my ISP is assigning me one network. Okay. In that network, how many sub networks I can design? So I have 16 bits to manipulate. How many I can have? These many departments I can have, which is not really possible for an organization having 65,000 departments, right? So these many subnets I can create. This is clear. Okay. Now let's talk about, when we were talking about subnet mask and all, we were talking that, okay, how many networks? So these many subnets you can create in one network that you have taken from the ISP. Now in one network, how many IP addresses you'll get? So how many host bits I have here? This is 48 plus 16, 64. Remaining 64 is what? Host. That means if I want to calculate total number of addresses per network, I will say what? 2 raised to power 64. We know what is the size of total size of IPv4? 2 power 32, which is somewhere around 4.3 billion. When you go 2 power 33, this will be 8.6 billion, double. 2 power 34, 17.2 billion. Imagine what will happen at 2 power 64, right? The number of addresses that you will get. So in IPv6, that's why we say the number of addresses is unlimited. Doesn't matter you want to use 2 addresses or 10 addresses, you waste everything, don't matter. Doesn't really matter. You can do that. Is that clear? So IPv6 subnetting also clear? Easy. Like I said, compared to V4, IPv6 is very easy. Okay. Plus secondary thing, you don't have to write subnet mask anywhere. Always just write the CIDR value. No subnet mask concept. Only CIDR. Even in the PC you assign, anywhere you assign, always you will assign CIDR only. You will never assign subnet mask. There is no subnet mask concept here. Clear? Yes. Yes. No, this is fixed. Okay. This is what you'll change. Okay. But if you want to further divide, then you have to go further. Okay. Like if you want that, okay, I just need 2 addresses only. Then you might go with, /127, where host bit will be 1. That means you will change here. Right. So that is a different part. But mostly this implementation will be here. Is that clear? Any doubt? Clear, right? Okay. Now, in IPv6, we do have some shortening methods. IPv6 address looks very long. So there are methods you can shorten this address. What are the methods? So consider here you have been given with the address. Okay, this is one address that you have been given with. You want to shorten this address, you will deploy the first rule. What is the first rule? That replace continuous 0 hex states with double column. If there are few hex states that are continuously 0, you can replace them with a double column. Doesn't matter 1 hex state, 2 hex state, 3 hex states, 10 hex states. 10 are not possible. Okay. So 1, 2, 3, 4, whatever the number of hex states are continuously 0, you can replace everything. If all 8 hex states are 0, you can replace entire IP address with double column. Okay. So you can replace it with double column. But here you have to take care of one thing, that double column can only be used once in an address. In one IPv6 address, you can use double colon only once. Now, according to this, what will happen? See, in this IP address, these 2 hex states, these are continuously 0. But also I have 1 hex state which is continuously 0. Okay. So one of them I can replace. If I want, I can replace this with double colon. If I want, I can replace this with double colon. but which will make my address more short? This one. So I'll replace these two with double colon, and this one I will keep as it is. Now, why we say that double colon can only be used once? Because if I will use in both the places, my system might get confused that here two hex states are 0 or here two hex states are 0. How you will come to know? Because you will assign the addresses in this form. If you don't have this restriction, you will say A triple one, B triple two, double colon, ABCD. Now your system will not understand here two 0 are there or here two 0 are there. There is no way for the system to understand this thing, right? So you can use it only once. So that means either you can write the address in this form, or else you can write it like 2001 0db8 0000 0000 A triple one, then you have B triple two, then double colon ABCD. So here your system can easily understand how your system knows in IPv6 8 hex state will be there. So I have the value for 1, 2, 3, 4, 5, and 6. Out of 8, I have 6. That means how many are 0? 2 are 0. And here 1, 2, 3, 4, 5, 6, 7 I have. 1 is 0. That's why we have this restriction. This is clear? Then second rule. What is the second rule? Second rule says eliminate all the starting zeros. All the starting zeros from each hex state. Now, after replacing with double colon, you can see in this hex state, I have a 0 in starting. In this hex state, everything is 0, but at least I have to keep one value. So 3 I will replace or eliminate. So this is how my address will become. This is clear? How you can shorten. Only two rules are there. Continuous hex states, replace with double colon. Starting zeros, eliminate. That's it. Yeah? Online people?
Can we make it like that? First, second one double time period, you know? Second zero and colon before zero can be used.
Yes, we can do.
But better option is.
Yeah, you want to shorten. Okay. This is clear? Okay. Now, let's see what are the different address types in case of IPv6. Okay. What happened? Any doubt is there? No?
Sir,
Yes.
sir, continuous three is what we
Doesn't matter.
what
3
to
are
do,
there,
sir.
4 are there, or entire IP address is there. Okay. This doesn't matter. Let's say, for example, you have an IP address something like 2001. So this is your IP address. Apply the first rule. From here to here, all are continuously 0. After applying first rule, double colon.
Okay.
Apply the second rule that eliminates starting zeros. Your address will become. See how short. Is that clear?
Okay.
Doesn't matter 2, 3, 1 or,
Okay.
or 8. We can replace. Okay. Now let's talk about the address types. So in IPv6, we have address types. Like first address type is what? Global unicast. So what is global unicast? As the name suggests, these are the addresses which are globally unique. Remember public IPv4 addresses? Same like the public address. Globally unique, used in WAN, okay, routable on the internet. You can use the internet using these addresses. Just the range is different. Okay. Just the range is different. Then we have second type of addresses, unique local. That means locally unique, unique in LAN, similar to your private IP addresses. Okay, not routable on the internet, used on the LAN site, free of cost, all these things. Okay, so you can see they are routable in the LAN only, and their range FC00:7. Now double colon means everything, all the remaining hex states, they are 0. Link local address, this is something new. Okay, this is something that we were not having in the V4. So see, in IPv6, what will happen that whenever you will assign an IP address, automatically the device will take one link local address. So that means it will have two IP addresses at a time, one link local and one physically what you will assign, manually what you will assign. Okay. So as the name suggests, these are unique on a link, not even a network, but on a link itself. Okay. So if you have a router, let's say, for example, so every interface of the router, they will have a link local address here also, and here also. So whatever the address is available here, that should be unique on this link. That means the address should not repeat on this side. That's it. But the address, same address you can use here. Okay. So by default, it will take automatically. These addresses will be assigned automatically. Okay. But you can also manually assign as per your choice. So like if you want that, okay, my one router should have one link local address only, you can configure the same link local address on all the interfaces. Okay. And these are not at all routable. They will be used for communication here only on that link. From beyond that, you cannot go. Okay. The range will be FE80:/. Okay. Then multicast, you remember, one-to-many communication. Class D in case of your IPv4. Here we have separate range itself. That is FF00:/. Okay. Anycast. Remember anycast? Unicast, multicast, broadcast, and anycast. That nearest node, right? More than one node will share the same address. So this is a shared address. And in IPv6, it is possible for two systems to have same IP address. You can see the range. Is that clear? That you will have more than one node that are using the same address and your message will be delivered to the nearest node. Is that clear? So these are the address types in your IPv6. Clear? Now I said that, okay, link local address, it will automatically select, but how your device will automatically select the link local address? How your device is going to take a link local address automatically? Because see, right now what I'll do is I'll take a PC. In the packet tracer, let me take a PC. Or here right now I have taken this server. If I go to the desktop IP configuration, you can see automatically link local address is already there. I did not configure anything. Or if I take a fresh system also, and if I go here to the system, desktop IP configuration, already it is there, right? So how the device is selecting this address? So it is using its MAC address to create a link local address. So we need to understand how the MAC address is getting converted into link local address. So I'm copying the MAC address of this device. Okay, now let's understand. The spectral will be, yes. So see here, the MAC address given to you is this. Now what you have to do, you have to go with the first rule. Okay. Rule number 1, add FF:AP in the center of MAC address and replace dot with column. Okay. So this is my MAC address. I'll go at the center. I'll add FF:AP. Add it. And these dots I'll replace with column. Second rule is invert the 7th bit. Okay. So if I see again, your MAC address is written in the hexadecimal form. That means how many bits are there? 16. 4 bits here, 4 bits here. 8 bits. Where will be my 7th bit? In this part, right? In this part, my 7th bit will be there. So I have to invert it. How? So first of all, I will convert it into binary. Okay. So if I will convert it into binary, see here, this is right now what I have, right? And if I convert it into binary, so it will be 0, 0, 0, 0, 0, 0, 0, 0. For 9, it will be 1, 0, 0, 1. And again for 0, 0, 0, 0, 0. So only first ACK state I have written in the binary. If I go for the 7th bit, 1, 2, 3, 4, 5, 6, 7. This is my 7th bit. Invert means if it is 0, make it 1. If it is 1, make it 0. So if I invert it 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0. This is clear? Okay. So this is my binary. This is binary after inverting 7th bit. This is clear. Now let's convert
Sir,
it back. Yes.
sir, only 7th bit it can
Yes.
invert, sir.
Only 7th bit.
After next octet remaining same, sir.
Yes, everything will remain same. Only the
Okay,
7th bit
one
you have to
bit will
invert,
be
rest of everything will be same.
Okay, okay, sir.
Okay. Now if I convert it back to hexadecimal, this will be 0, this will be 2, this will be 9, this will be 0. This is what? Hexadecimal. Right? So that means this time what it will be? This is it. And this will change to 2 after inverting the 7th bit, correct? Now, next rule, add FF, sorry, add FP80 double column in the starting of the address. Okay, you have to add FP80 double column in the starting of the address. This is your address. And the starting of this address, you will add FP80 double. Done. Double column means remaining all the X states 0. Okay. And last rule, apply IPv6 shortening rules. So already double colon is there. First rule will not be applicable. Second rule only will be applicable. That you have to do what? You have to eliminate starting zeros. So this is my new address. And here I have added FP80 double colon. And according to second rule, starting zeros will be eliminated. Only this will be eliminated. And this is what? This is your link local address. This is what? This is the one we have calculated. Okay, now let's go and check the one that is there in the device. This is the link local address. Copy. Now I'll change the color so that you can differentiate. This is the one that is available in the device. These are the 4 rules. You have to add FF colon FE in the center and you have to replace dot with colon. Invert the 7th bit, add FE80 in the starting and apply the shortening rules. Yes. So this will what your device will automatically do, not me. Okay. This is clear. How your device will convert the link local address into, sorry, MAC address into link local address. Okay. All right. Then let's talk about, this is done conversion of your MAC address to linked local address. Now let's talk about features of your IPv6. So in IPv6, we have unicast, multicast, anycast, but there is no broadcast. Broadcast problem solved in IPv6. Okay, because of broadcast, we were having so many problems. In IPv6, no broadcast. Then auto configuration for stateless and stateful. See, in IPv4, if you want to automatically assign IP address, you have DHCP, right? DHCP we have in the V6 also, and it will be known as DHCP V6. Okay, but this is DHCP is a stateful way of assigning IP address. What is stateful? That means maintaining a record of what IP address has been assigned to what system. DHCP keeps a record, but for security, because right now IPv6 is having unlimited number of addresses. That means directly to the systems we are assigning public IP address, and public IP addresses can be tracked, right? So for that reason, we require stateless configuration also. That means nobody should have a track of information. Nobody should have this information, what IP address has been assigned to what MAC address. So devices, they are automatically configuring their addresses. For that reason, you have some ways. One is EUI64. EUI64 is exactly similar to your, like how it converts MAC address to linked local address. Just the difference is the first 64-bit. The first 64-bit, it will be advertised by your router. That means the network ID will be advertised by your router, and remaining 64-bit, your device will calculate automatically. How? MAC address is there, invert the 7th bit, and it becomes your remaining 64-bit. That means you have to just apply the first rule and second rule only. You will add FF colon FE in the center, replace dot with colon. So automatically 48 bits, MAC address is 48 bit. And when you're adding 4 more digits, automatically 16 bits you're adding. It will become 64 bit. 64 is advertised already. 64 you have. Just for some security, invert the 7th bit. And this is your new address. This is the EUI64 scheme. Then you have one more scheme, which is Slack stateless address auto configuration. Okay, stateless address auto configuration. So in that, device will take the 64-bit from the router advertisement, and remaining 64-bit it will randomly calculate, because number of addresses are very used. So device will automatically calculate it. Okay, and in the EUI64, these 64 bits you will tell, and then to the router you will say use EUI64 scheme. Router will form this method. Remaining 64-bit, router will calculate. Clear? Okay. Then when IPv6 was designed, all the problems in the IPv4, they were rectified. Okay, like in the IPv4, they had to later come up with a NAT solution, that if the addresses are limited, later on they had to come up with a NAT solution. Here already it is there. So here you do not require it, but you can do it. It is available already. It has native support for IPsec. IPsec is a protocol suite which is used for providing security to your VPN tunnels. Okay, so in your NP advanced, you will study about VPNs. You will be configuring VPNs. Okay, so there you will understand what is IPsec, what is IKE version 2. Okay, all these things there you will be studying. Obviously, all the problems rectified, so the header was also improved. Whatever the problems were there in the IPv4 solved in IPv6. And IPv6 also has anycast support. Okay, all right.
But this is possible in the
No, not at all. All you need to know is just the starting part. That's it. Remaining randomly devices are automatically configuring it. Why you need to remember it? So only 64 bits you need to know. Not even 64, only 48. Okay. This is clear. Now let's talk about routing in IPv6, and you will see how easy it is. Same sort of topology I'll create. R1, R2. Connected to each other. Between R1 and R2, we will be using a network 2000:/64. See how easy it is. Then loopback you will be using 2001:2/64, 2002:2/64. So your network ID will be everything 0, 2002:. Okay, because the first address is 0, that is your network ID. /64. Comments also very easy. Okay, so here the address we will be using, like this is a network ID. So if I want to use the address, the first address will be 2000:1, and this side the address which will be there 2000:2. Last hex state I'm changing, right? Okay, let's go to R1. Okay, go to R1. This is R1. Enable configuration terminal, hostname R1. Now, how do you check IP configuration in the IPv4? If you want to check what all the IP addresses you have configured on the device, show IP interface brief. In IPv6, what you have to take care of? Anywhere you're using the word IP, replace with IPv6. All your comments are done. In place of IP keyword, use IPv6 and all your routing commands are also there. See, show IPv6 interface brief. Do I have to use here? And you see, we are able to see the IPv configuration. Right now, my interfaces are down and IP address is not assigned. Now, let's say I want to assign interface gig 0/0. How do you assign IP address in the v4? And here it will be, that's it. IPv6 address, and the address you want to assign 2000:1. Subnet mask concept is not there. See ADR value, done. Okay. No shutdown. Same comments, exactly same. Okay, same way. Okay, R1 configuration is done already. Let's go to R2. Say no. Enable configuration terminal. Host name R2. Interface gig 0/0. IPv6 address 2000:2/64. Motion. Now loopback interfaces we need to set. Interface loopback 1. IPv6 address 2001:2/64. Then interface loopback 2. Now who says IPv6 is complicated? Not really complicated. Very easy. Compared to v4, at least you don't have to write subnet mask also. Then check do show IPv6 interface brief. All the IP addresses are set, and you see along with the IP addresses, automatically linked local addresses are also set. And these are the IP addresses we have configured. Now let's check the routing table. How do you check the routing table here? You say you check show IP route. Now we will check show IP v6. Same routing table. Okay, you have only one connected route, which is 2000 network. This one. There is no route for 2001, 2, 3, and 4. Right? So if I try to ping, first of all, let me try to ping the other router 2000:2. Able to ping. That means this IP address I'm able to ping, and I'm not having a route for 2001, 2, 3, and 4. Let's configure the route. Static route first. How do you configure static route? IP route. Here it will be IPv6 route. Network ID. So this is an IP address. If I will make it 0, it will become network ID. So I'll say 2001 /64. Network ID and subnet mask done. Network ID and subnet mask done. What will be the next hop address? R1 will send the information this side. My next hop address is this one. So I'll say 2000 :2. My route is done. Okay. To ping 2001 :2. You have the communication, right? Same way, you can configure a route for 2002 also. And you can ping it. Check how the static route looks like. Do show IPv6 route. This is your static route for 2001. This is for 2002. Is that clear? Okay. Now let's say for 3 and 4 and 5 and 6, whatever the networks are there, I'll have to go via the same path. So rather than configuring static route, I can configure a default route. So how do I configure a default route? IPv6 route. Now in IPv4, we said 0000. IP address completely 0. And in IPv6, if everything is 0, double colon you can replace. So that means this is my network. That's enough. Okay. And subnet mask also 0. Subnet mask also 0. All I need to give is what? My next hop address. 2000 :2. Okay. Do pin, and you can see here. Do show IPv6 route. I don't have any specific route for 2003 and 4. I just have a default route for 2001, route for 2002. There is no route for 3 and 4. And I will ping to ping 2003 :2. I have the communication. 4 also have the communication. See how is it? Understood? And in your IPv6, we don't have ARP also. So no proxy ARP and all those problems, nothing. Okay. In IPv6, your ARP has been replaced by one protocol, that is ND, Neighbor Discovery Protocol. It will automatically discover no ARP process. Okay. Yeah, then IPv4, definitely. But slowly they are moving. Like if you are using Geo SIM cards, okay, you are getting IPv6. Okay, Geo network is completely based on IPv6 only, no IPv4. If you are using Airtel and all, you in some people of you might be getting V4, some might be getting V6. That will happen. Okay. So this was your IPv6. Any doubt? And tell me if it is complicated. Is it? No, right? See, once you learn V4, V6 is nothing. Only few things about the address you need to remember. That other than that, it is more easy than V4. Configuration wise also. Like, yeah. So many things you have to do there. Here, subnetting easiest. So, any doubts? No? Online people?
No, sir.
Okay. Then next thing we have, are we good to go or enough for the day? You can tell me. See, we have till this weekend. Enough time we have to complete. I know. If we go in this pace, tomorrow it will finish. So you can let me know. Now we just have these architectures, that how the networks are designed. Going worst. What about online people? No response.
What's up?
You want to complete it today or tomorrow? Or like, is it happening too much for the day? Can we continue tomorrow? Sure, we can continue tomorrow.
So there is
Tomorrow,
one
Fine.
topic also remaining.
Sorry.
The topic which I have told you.
Yes,
um,
don't worry. I have already added it. Okay.
okay.
Yeah, I have already added all those topics, and this curriculum, what you're studying, it is covering both 1.0 and latest version 1.1 also. Okay.
Okay.
Yeah.
So the AI topic is going to be explained by you tomorrow.
Yes, probably tomorrow if we have time. If not, then Wednesday. Okay.
Okay. Okay.
And if you see here, see, let me show you this thing. About the AI topic, let me show. This is the new version 1.1.
Yeah.
So you just have that, you have to know how it can be used. What is the use of AI in the network operations? Okay, so it will be like barely 2-3 minutes topic. Don't
Okay.
worry. Okay, so we'll cover everything. The newer one,
Okay.
I'll cover it.
Okay. And so what about the dumps?
Terms we are not providing. Okay, so you have to go and check for certain websites. Yeah.
So just to give some idea about the where we can get
Source.
the terms and all.
Okay, let me stop the recording.